Okay, so what we're going to do today is measure the void content of our compacted sample. Now, if you remember when we made this sample, we had all of our aggregate, sand, gravel, and our screenings, along with our binder, and that was compacted in our gyratory compactor. There's one other component that we have to measure, and that's our void content, or air. So what we have to do is we have to get our density of this part, and we take the exact same mix design but uncompacted. We draw all the air out of it in a vacuum pot and then get its density. Plug those two densities into a formula, we'll find our void content. So some of this stuff I've already done. In our tank, setting in 77-degree water, I have a compacted sample. This particular scale can measure on top or on bottom. So my dry weight that I measured on top was 4696.4 grams. Suspended in this tank, its weight is 2670.0. Then we also have one more weight, which is a surface saturated weight. So we'll pull our part out of here, and I'll just quickly blot it off, because this sample is going to absorb some water. We'll let that stabilize. Then we'll get its weight. 4699.3. Okay, so I'm going to do a little math here, then I'll show you the results. Okay, so our formula is our weight in the air divided by the weight of the surface saturated sample minus the weight suspended in the water, gives us a maximum density of that compacted sample of 2.3143. Now we have to do the same thing for our uncompacted sample. And what I've done is this pot that we're weighing this in has a wet weight and a dry weight. So I filled my sample into here dry with no water, subtracted the weight of the pot, and my sample that I'm testing is 1,531.6 grams of this uncompacted aggregate. So we'll turn off our vacuum. We also have a shaker that sits here and shakes this part. You have to bleed this off real slow so it doesn't boil over on you, because this is at a pretty strong vacuum. Okay, so this is our pot right here. It's got that sample in it. All the air has been drawn out of it. And my dry weight of this tub, this little pot, I've got it written on the side, is 2740.4, and its submerged weight of just this empty pot is 1728.3. So whatever weight I get, I have to subtract that weight. So you have to real carefully load this down in here so you don't float any particles out of it. Got a little cradle in the water tank. Okay, now we'll let this sit there for a little bit. The spec calls for it to stay submerged in a tank for 10 minutes. That's to make sure everything stabilizes, but we'll just watch it for the sake of time. Once it looks like it's a stable weight, I'll take that reading. All right, so let's see what we get for our weight. Still dancing around a little bit, but we'll kind of take the average. Remember, I have to subtract the weight of this pot. We'll call it that. All right, have another little formula here to do, which I'll show you in a second. All right, so there's that little formula. And what we've done is we've taken our dry weight, submerged weight, put into this formula. The maximum density of our uncompacted sample is 2.4048 grams, or specific gravity rather. So now I've got another formula I have to run and put the specific gravity of our compacted sample, specific gravity of our uncompacted sample. That'll then give us our void content. Okay, do that math. Okay, so we had our specific gravity of our compacted sample, specific gravity of our uncompacted sample. We plug it into this formula and we calculate it out to 3.763%, which was right where we want to be for our target. And I believe the spec is 3.5 plus or minus 0.5, I do believe, for this particular mix design. So that void content, or the air in the sample, is within our spec. If it wasn't, we'd have to go back and change our mix design to get that.